All right, guys, this is a reminder Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class for your own security reasons. So we are in the December 17th attendance ticket. Please give me a green check when you've got that open and ready to go. Waiting on Angelina, Sienna, Ciara, Dalen, Haley, Jacob, Jackie, Jeremy, Tucker, Johnny, Josh, Kyrie. Let's see here, Rachel, Saul, Siva, Stephen, Ty. Green checks all around, please, if we have our ticket open. Good to go. Passwords in the chat box for you. Looking good. Thank you, guys. No worries, Angelina. Okay, here we go. So we are, I keep on forgetting to put this up here. We have 16 days left of the quarter number 2, and then classes will be over. So please keep that in mind. Make sure you are catching up on any of your missing work. At this point, we have done 4 out of our 5 labs. So you really want to make sure you do your lab reports. Currently, each lab is worth about 7% of your grade. And don't forget your midterm exam. Your midterm exam is currently worth 15% of your grade. So those are really big assignments. We really got to make sure we are getting those taken care of. Smiley faces if we feel good about that. Thumbs down if there's any confusion about that. Looking good. Okay, so today we're talking about ionic and covalent bonds, and that is just the 2 main bonds of how atoms bond together. Tomorrow we'll talk a little bit more about electronegativity and some other types of bonding that are a little bit less familiar to us. Wednesday we have a game day. Thursday, Friday, we are starting Unit 8 because we are in Week 8, guys. We have 11 weeks in this quarter, so it's going by fast. More like 10 and a half weeks, but and then we will be talking about chemical reactions for unit number 8, and there's a really cool lab on Friday as well. Let's keep on going. So the focus of this unit is bonding. We're taking a look at how electrons, I'm so sorry. You know what? Actually, there should not be anything on this Friday. You guys are totally correct. That is definitely an error on my part. I am so sorry. There is no school on this Friday. Yay! Yeah, we are on winter break on Friday. I don't know why I put that there. That is totally my bad. Sorry, hold on. Oh yeah, did you? Cool, Steven. So you should be a little bit familiar with it, right? Maybe. That might have been a while ago. Cool, guys. So that being said, we're talking about bonds. Let's go ahead and jump into that. So today we're going to talk about ionic and covalent bonds and their properties, and we should also be able to define polar and nonpolar molecules. Yeah, I know. I definitely forgot that too as well, Ariana, obviously. Okay, so let's go ahead and talk a little bit about ionic bonds. So first off, the word ion means that it is an atom with an overall charge. So it's either positively or negatively charged. So let's talk about this. Remember, the only way we can change charge is by changing the electrons. We can't be changing protons because protons are stuck in the center of our nucleus, and they are critical to the identity of the atom. So we're not changing protons. Instead, we're just giving or taking electrons, right? Just like we talked about before class started, giving and taking within friendships, right? So let's talk about if we gain electrons. Remember, remind me again in the chat box, are electrons positively or negatively charged? Tell me in the chat box, are electrons positively or negatively charged? Go ahead, get your answer in the chat box. Awesome. I see Diego. I see Andrew, Steven. Thank you for your participation. Yeah, they're negatively charged. So let's talk about this. If we gain electrons, we are essentially gaining negativity. So should we become more positive or more negative? If we're gaining electrons, gaining negativity, do we become more positive or more negative? Tell me in the chat. Yeah, exactly. Gaining negativity. That's the way I like to think about it. Yeah, you become more negative, right? So let's talk about it. 8 protons, this is going to give us a positive 8 charge. And 9 electrons will give us a negative 9 charge. And tell me in the chat box, what does positive 8 and negative 9 give us? So think about 8 minus 9 or positive 8, negative 9. How do we talk about that? Yeah, that's going to be negative 1. Absolutely, we got that. So that would be a negative ion. Smiley faces if that makes sense. This would be an ion with a negative 1 overall charge. Perfect. Okay, now let's talk about the opposite. Let's say we lose electrons, so we lose negativity. Hopefully we should see that we become more positive. So same thing, we've got positive 8 protons and negative 7 electrons. What is my overall charge? What is my overall charge? Yes, positive 8, negative 7 is going to give me a positive 1. Absolutely. So there's a nice nifty diagram down here where you can see this, right? So losing electrons, you actually become more positive. Gaining electrons, you actually become more negative because electrons are negative. Now, some naming, right? You can see that there are actually some names for these. So ions that are positive are actually called cation ions. Okay, not cation. This is cation ion because it's still an ion. And you'll notice the letter T kind of looks like what sign? Tell me in the chat box. The letter T kind of looks like what kind of sign? Yes, it looks like a positive sign. So that's how you can remember cation means a positive ion because there's a T in it that looks like a positive sign. Smiley faces if that makes sense to you. Smiley faces if that makes sense to you. That's the way that I remember that. Plus, cats are just, you know, they make you happy. So cat's positive. And obviously, if they're positive, it means it has more protons than electrons because there are less electrons. We've lost electrons, right? Anion, okay, the way I remember this is instead of a T in the center of it, it has an N, and N stands for negative. So N for negative, T for it looks like a positive, N for negative. So anions are what we call the negative ions, and in this case, they have more electrons, more of the negative particles, okay? Now, let's remember really quickly that the number of protons is the atomic number, which is the identity of the atom. So in this case, both of these atoms we just talked about must be what? Are they going to be nitrogen, oxygen, or fluorine? Think about this. Look at the number of protons, 8 protons, and that should also tell us the atomic number. So tell me in the chat box, nitrogen, oxygen, or fluorine. Both of these atoms right here should be what? Both of these atoms should be what? The fact that the number 8 is super important. So 8 protons means an atomic number of 8. Which of these has an atomic number of 8? Nitrogen, oxygen, or fluorine? Yeah, exactly. So both of these atoms are actually oxygen. Smiley faces if that makes sense. So even though one is negatively charged and one is positively charged, they're still both technically oxygen because they both still have 8 protons, and 8 protons is always identity. Cool. All right, now let's talk about this. So now we've talked about cations and we've talked about anions, and now here's the thing. We can see this here, that opposites will do what? Tell me in the chat box. They say that opposites do what? Opposites do what? You can see it in our little comic here. Yes, opposites attract, right? So if we have a cation, we have an anion, they're going to fall in love, they're going to want to be together, they're going to make a friendship or a marriage, I don't know, whatever. So here's the thing, guys. Remember that when we have atoms, they want complete valence electrons. And the way that they get complete valence electrons is by gaining or losing electrons, which means that they become either positively or negatively charged. And if you get 2 atoms that really want the same thing, where one becomes positive, one becomes negative, then they're going to be attracted to each other and they are going to bond together. So salt is a great example of this. So sodium, the abbreviation of sodium is Na. I don't know why. That seems like an odd abbreviation, but this abbreviation for sodium is Na. Now, sodium has 1 electron on its valence shell. And is it easier to gain 7 more or just to lose the 1? Is it easier to gain 7 more to get all 8 or just to lose 1? Yeah, it's definitely easier to lose 1. So sodium wants to lose this 1 electron. All right. Now chlorine, all right, is going to come along, and chlorine already has 7 electrons. So what does chlorine want? If chlorine already has 7, what do you think chlorine's going to want? Yes, it's going to want to gain 1, right? So sodium wants to lose 1, and chlorine wants to gain 1. So what do you think? Is it going to be a beautiful partnership or what? Think it'll work? What? Steven, you're so negative. Yes, it's going to be a beautiful partnership, okay? So here's the thing. Sodium will lose the electron, okay? And if it loses the electron, loses negativity, does it become more positive or negative? If we're losing negativity, losing negative electrons, are we more positive or negative? Tell me in the chat box. Yes, we become more positive, all right? So sodium's going to become positive. And remind me again, does that mean it's a cation or an anion? Let's fill this out. Is this a cation or an anion? Remember, the positive looks like what letter? Yeah, it looks like the T in cation, so this is the cation. And now chlorine's going to come along, and chlorine wants to gain that electron. So chlorine's going to take that electron, making it what? If it takes a negative electron, it becomes what? Tell me the charge, tell me the name of it. Yeah, it's going to become an anion because overall its charge becomes what? Its charge is what? Positive or negative? Negative, absolutely. Okay, so we can see here that sodium, when it loses that electron, becomes positive. Sorry, yes. And then chlorine, when it gains that electron, becomes negative. And now that they are oppositely charged, they are going to be bonded together. They are going to be attracted to each other. So they're going to go ahead and form a partnership, bond together. So this creates sodium chloride, NaCl, which is also known as what type of salt? Tell me in the chat box. It's also known as what type of salt? Yeah, table salt. Table salt. Okay, smiley faces if you guys feel good about this. You should be able to really understand this comic here now. We've got positive sodium, negative chlorine saying, they say opposites attract, baby, I got my eye on you. And this one is OMG. Great comic. Cool. All right. So again, this is just kind of zooming in on that picture. So you see sodium gives its electron to chlorine, becoming positively charged. Chlorine becomes negative charged. They hook up together. They're in love with each other. Okay? And this one is just a funny one where over here you can see this guy, he's got his one electron. So he gives this one electron to this guy. And now he's so sad because he's negative and this guy is positive. So I don't know if he did a good deed or not, but he feels good about it. All right, let's make sure this makes sense, guys. Grab your whiteboard tools, match these up, please. We've got cation, anion, and what an ionic bond really is. Go ahead, match those up on the whiteboard. Perfect. All right, guys, let me go ahead and grab my red tool here. Looks like we are all in agreement, so it looks like we really understand this. Let me shrink these down a little and then get ready because this is number 1 in your ticket. You're getting that filled out as well. Lovely. Okay, so yes, cation is a positively charged ion, has more protons than electrons. An anion is negatively charged. It has more electrons than protons, right? T looks like a positive, N for negative. And then ionic bond is just the attraction between those two types of ions, positive and negative. Opposites attract. This is number 1. I'm going to give you 30-second screen checks when we have number 1 saved in our attendance ticket. Go, go, go. All right, perfect. Just waiting on a few more green checks. Let's see here. Angelina, Annalise, Sienna, Destiny, Elijah, Jackie, Jeremy, Tucker, Johnny, Josh, Kyrie, Kevin, Melissa, green checks, please, and Saul and Ty, green checks for number 1, please. Let me know if you guys need any help. Perfect. Okay, guys. So just like what we just saw, sodium is a metal, and metals like sodium generally have very few valence electrons, and so it's much easier to lose them. They're losing negativity, which makes them more positive. They become our cations. Nonmetals, on the other hand, like our chlorine is like a gas. This one has many valence electrons. And as a result, they just need to gain a few more, making them negative because they're gaining negativity. They become our anions. And you can see this up here on our board here, right? You can see the metals on the left becoming positive because they're losing their few electrons. And the gases, nonmetals on the right that are gaining electrons, becoming more negative. Smiley faces, guys, if you feel comfortable with that. Thumbs down if we have any issues understanding that. Looking good. Perfect. Okay. So here's the thing, guys. Ionic compounds have some interesting traits. So ionic compounds are crystalline. So how many of you guys have ever looked very closely at a piece of salt? What does a piece of salt look like? Have you ever looked at it under a microscope? Or even if you just have a large piece of salt, what does it look like? Tell me in the chat box. Yeah, it's square like a crystal, exactly. So sodium and chlorine come together in a crystalline or cubic arrangement. So ionic compounds are always crystalline looking, okay? They look like crystals, okay? And the reason sodium and chlorine stack together like this in a cube is because it takes the least amount of energy and space in order to do that. So the thing about salt is that even if you break it down into smaller pieces, it's still going to have this this cubic shape where sodium is connected to chlorine, which is connected to sodium, which is connected to another chlorine, and so on and so forth. Smiley faces if that makes sense, guys. This is different than like sugar. Sugar is not an ionic compound. We'll talk about that in a little bit. But sugar can be like ground down into dust and it won't be cubic anymore. So even though it might come in sugar cubes, it's not actually cubic when you look at it molecularly. Okay? Cool. Now, because of this structure here, do you guys think this is going to be a weak or a strong structure? Tell me in the chat box. Do you think this would be a weaker or a stronger structure? Think about if you wanted to kind of like step on top of this. What do you guys think? Yeah, this is definitely a very strong structure. So ionic bonds are actually very strong bonds, and because of this, they tend to be solids at room temperature, which means it takes a lot more energy to melt them or even to boil them. Okay, so think about the fact that if you've ever tried to like put salt on your pan just by itself, does it melt? Does salt just melt by itself on a pan? No, it doesn't. Now, sugar, you can actually melt by itself on a pan. What does sugar become? Sugar is not ionic, which is why sugar is not as strong. So sugar will actually melt on a pan and eventually become what? What's that like a burnt sugar called? It's not really burnt. Caramel. Yeah, it becomes caramel. Exactly. So here's the thing. So ionic bonds like salt, they're stronger bonds. They're usually solids. They have higher melting and boiling points. Now, here's the thing though. Most ionic compounds are soluble, which means that they dissolve in water. And we'll see a little bit later, but water has slightly positive hydrogens and slightly negative oxygens. And because of this, it's really good at tearing apart the positive and negative ions in salt. Take a look at this picture up here. Okay, so you can see we've got these little waters, and these little waters are taking apart these ions, right? So the positive hydrogens are pulling away at the negative chlorines, and the the negative oxygen is pulling away at the positive sodiums. Okay, so they're pulling each other apart, kind of taking them apart. Smiley faces if that makes sense. Yes, exactly, Stephen. Okay, now because of this, right, so we're able to dissolve salt into solution. And again, in solution, you actually pull apart the separate positive and negative ions. And because you're actually pulling apart these ions, if you stick like a wire into a solution and you stick another wire and you connect it to a battery and a light, you can actually and you connect it to a battery into a light, you can actually turn on that light because solutions with salt in them will actually conduct electric current. They will conduct electricity because those positive and negative ions can move. Smiley faces if that makes sense. I love it. We're sharing kitchen tips in the chat box. Cool. Okay, guys, so now let's talk about the second type of bond, of how we make other types of molecules in chemistry, okay? Now, let's talk about these. So, covalent bonds, no worries, Haley. Covalent bonds are actually the sharing of valence electrons. Remember, in ionic bonds, did we share the electrons? In ionic bonds, were the sodium and the chlorine like both holding on to that one electron? Were they both holding on to it? Were they both holding on to this pink electron? No, they were just giving it away, right? Sodium was just like, I don't want it. You can have it. Keep it. Okay? And chlorine was like, thank you. I will take this, right? Now, in covalent bonds, though, covalent bonds don't do that. They actually will share the electrons, and they will both hold on to the electrons together, okay? Now, generally, this happens between nonmetals, right? So two nonmetals together will actually share electrons because neither of them is strong enough to completely remove an electron from another. So we'll see a little bit later tomorrow that chlorine is strong enough to actually pull away an electron from sodium, but not when it's between two chlorine atoms, between two non-metal atoms. So they have to share. Smiley faces if that makes sense, okay? Covalent bonds are sharing, ionic bonds are giving and taking. Okay, so we'll see a little bit of that a little bit later. Now, your human body is actually really reliant on covalent bonds. So how many of you guys have ever seen these before? Proteins, carbs, lipids, and nucleic acids. Okay, these are the four main parts that your body is made up of. Have we seen this? We should have seen this in what class, hopefully? What class have we seen these? Yeah, definitely. Hopefully you've seen these in what? Biology? Does that sound familiar at all? Okay, so proteins. Proteins are important. What do your proteins help you build? What do proteins help you build? Tell me in the chat box, what do proteins help you build? Yes, the one with the plant nerds. They help you build muscle. Yes, so proteins, your muscles are mostly made up of protein. That's why you take protein shakes after you exercise. Your hair is made of protein. Your nails are made of protein. Your immune system relies a lot on proteins. Your proteins in your blood are actually what are carrying oxygen throughout your body. So proteins have many roles. Proteins are very important. Carbohydrates, right? You think about starches and breads and vegetables and sugars. Carbohydrates are really important as well because they're the main giver of fast energy. Think about this idea of carbo loading. How many of you have ever had to run a race and the night before you carbo load? Does anyone know what I'm talking about? Tell me in the chat box. Is that familiar? So carbohydrates help give us fast energy. That's why sugar makes us hyper, gives us fast energy. Lipids, what's another word for lipids? What's another word for lipids? And again, all of these are covalent. They're all made from sharing electrons together. What's another word for lipids? Insulin is actually a protein, but lipids, nope, sugar is a carbohydrate. Does anyone know? Lipids are actually fats, right? So fats are your long-term storage. Yeah, right, like cholesterol. Yeah, sort of. So lipids are going to be your long-term storage. Fats store your energy for a long time. That's why it's so hard to get rid of fat. And nucleic acids, there is one really important molecule in your body that includes the word nucleic acid. It's called deoxyribonucleic acid. Does anyone know what that is? What's the abbreviation for deoxyribonucleic acid? Nobody knows? DNA, yes. And why is DNA important? Tell me in the chat box, why is DNA important? This is all just review of biology, so hopefully you're remembering back to this. Why is DNA important? Yes, it's your blueprint, right? Your DNA has all of your genetic information, which is how your body was built, right? And how your body continues to grow. Absolutely. It's why you have the color hair that you have. It's why your organs are where they are. It's why you have the color skin you have or the color eyes that you have or why your nose is crooked when your sister's is not, right? Okay, so here's how this works. So covalent bonds, again, they are all about sharing. So chlorine has 7 valence electrons. And remember, it wants 8 in total. So that means chlorine needs how many more? We just went over this. If chlorine has 7 valence electrons but wants 8 in total, how many more does it need? Yes, it needs 1. Okay, but one chlorine can't just give its electron to another chlorine because then the other chlorine's happy, but it's no longer happy. It now only has 6 valence and it's not happy. So instead, they're each going to share 1 electron with each other. So take a look here. So we're going to have this guy share this electron with chlorine, and this guy share this electron with chlorine, and they're now both sharing these 2 electrons. They're both sharing these 2 central electrons right here. Smiley faces if you can see that. I know it's a little bit tiny. Let me know if we can see that there. Smileys, awesome. Okay, cool. So what happens now is if you go around the circle, for this left chlorine, how many electrons are on its circle now? Because of this sharing, how many electrons do we now see on this left chlorine's valence? Yeah, you see 8. What about on the right? Does the right one also have 8? Does the right one also have 8 on its ring? Yes. So because of sharing, they seem like they are full and therefore they are happy. This creates a different type of bond, the sharing bond. So now we have what's called a dichloride molecule. And dichloride molecules have completely different properties than just chlorines by themselves. So remember, by creating bonds, not only are we making happier atoms, but we're also creating things that have new and different properties. Okay, so we can see another example of this right here. So carbon has 4 valence. Each hydrogen has 1. And they share their electrons together. And the result is, take a look at carbon right here. You can see now on its circle, it actually has all 8 electrons that it needs, and each hydrogen on its circle all looks like it has 2 electrons. So this is a lot like sharing a blanket, right? You don't just need for every single person to have their own blanket, right? If you're hanging out with a friend, right, we've been talking a lot about friendships. Friendships are all about bonds, which is also what we're talking about. You don't need to have separate blankets. Instead, you can each share one blanket and both be happy. Smiley faces if that makes sense. So they're sharing electrons, and because of that, they're both happy. So just by sharing, they can both be happy. Awesome, cool guys. So this is the way that I remember this. So for ionic bonds, you can say the name's bond, ionic bond, taken, not shared. Does anyone know that reference? I really hope you do. I'll be sad if you don't. Yes. Whereas covalent has this prefix co, and anytime you see this word co, this prefix co, it means like togetherness. So to cooperate means to work together. Co-ed means both women and men within the dorm, right? A co-ed dorm. It's both cooperating, right? Smiley faces if that makes sense. So covalent means they're cooperating, they're sharing, they're good friends. You can see here ionic, they're actually just taking away an electron. So he's kind of like a bully. Ionic is more like a bully. Okay, thumbs up if that helps you better remember ionic versus covalent. Okay, ionic versus covalent. Ionic is taking, covalent is sharing. Awesome. Now, the properties of covalent molecules. Covalent molecules are not stuck inside of that lattice, that crystalline structure. So covalent molecules just aren't as strong. Okay, so covalent properties, they're just not as strong as ionic ones. So as a result, since they're not as strong, they don't stay solid, right? They have lower temperatures, lower melting and boiling temperatures. They form liquids and gases at room temperature because they're just not as strong of bonds. Now, unlike ionic compounds where the ions can separate from each other in solution, where we've got a bunch of positives and negatives, covalently bonded molecules will stay intact. So even if they're dissolved and they kind of disappear in water, if you looked at it molecularly, they would still be completely attached together. Unlike ionic bonds where the ions separate. Smiley faces if that makes sense. You can see a picture of that down here. So salt when dissolved, the positive sodiums, negative chlorines separate. Sugar, on the other hand, when it gets dissolved, does not separate out. Okay, so the result is if sugar does not separate, do you see any positives and negatives in sugar solution? Take a look here. Do you guys see any positives or negatives in the sugar solution? No, and if there's no positives or negatives, do you think that it can conduct electricity? If there's no positives or negatives, can it conduct electricity? No, definitely not, right? So salt in solution can conduct electricity. I don't recommend you doing it because you probably don't know what you're doing yet, but it can conduct electricity. I'll show that to you sometime. Sugar, on the other hand, cannot. Sugar just doesn't have that ability, okay? So again, ionic, strong, conducts electricity, crystals, they're solids. Over here, right? Covalently bonded molecules tend to be liquids and gases, right? They're weaker. They cannot conduct electricity. Okay, cool. So let's make sure that makes sense. Grab your whiteboard tools, match these up, right? Ionic, covalent. Go ahead and match those up. Go, 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 go. I know, Kendra. Resist. Don't play with salt solution and batteries, please. Looking good. Get your answers up there. I love it. Looks like we have a lot of agreement. We'll see if we agree correctly. Oh no. Why do you have salt solution right next to you, Stephen? Because you could accidentally electrocute yourself if you don't know what you're doing. That's why not. Cool. All right, let me go ahead and pause these tools. Let's make sure that this makes sense. This is also going to be number 2. All right, so make sure you get your mouse ready. Here we go. Okay, so let's match these up. So ionic compounds, yes, they have high melting points. They're usually solids. Again, ionic bonds, taken, not shared. Electrons are given and taken. And in this case, remember those ions can separate from each other, which means that they can conduct electricity. Awesome. Now over here, covalent. Covalent is low melting points. They're weaker bonds. Their electrons are shared. Okay, and as a result, because they aren't positives or negatives being attracted to each other, they are unable to conduct electricity because when you dissolve them, they don't separate into positives and negatives. This is number 2. Give me a green check when you have this saved. I'm going to go ahead and give you 60 seconds. Does that sound good? Go, go, go. Here we go, guys. Green checks when you have that saved. Go. All right, waiting on a few more green checks. So let's see here. Annalise, Destiny, Edgar, Elijah, Haley, Jacob, Jeremy, Jonathan, Johnny, Josh, Kyrie, Kevin, Melissa, Saul, Seha, Steven, Ty, Steven, focus. Oh yeah, no worries, Seha, here you go. All right, and whatever you missed when the recordings were posted, you can go ahead and go back to it because I won't have time after. Cool. All right, guys, let's keep on going. So here's the thing, guys. Molecules, specifically covalently bonded molecules, can either be covalently polar or covalently nonpolar. And the way that this happens, no worries, Haley, I hope you're okay, is based on their shape because of electron interactions. So nonpolar covalent molecules are balanced, right? So they're completely symmetrical, which means overall they act neutral, right? One side doesn't act more positive than the other side. Polar molecules, on the other hand, just like the word polar, have opposite poles, right? If you think North Pole, South Pole, positive pole, negative pole, that is what polar means, is that they have opposite sides, okay? So because the reason that this happens is because the electrons are unbalanced, resulting in something that's not symmetrical. And if it's not symmetrical, one side's going to act more positive and one side's going to act more negative. Smiley faces if that's starting to make sense. Yeah, is your dog okay? Smiley faces, guys, if that makes sense. All right. So water is specifically the most famous polar covalent molecule. So water has an oxygen on it with 2 pairs of negative electrons. And those 2 pairs of negative electrons, remember, likes will repel. And so those 2 pairs actually repel from each other and push each other away. And what this does, it is that it actually squeezes together the hydrogens. And as it squeezes those hydrogens together, it actually creates a bent shape. So smiley faces if you've ever seen water drawn like this. Smiley faces if you've seen water drawn like this. Awesome. Yes, so water is always drawn in this bent shape, and that is because in reality, water is in fact a bent molecule. Okay, it has a bent shape, and the result is that one side of water actually acts more negative, so the oxygen acts negative, and the hydrogens each act positive, which again is why water is so good at dissolving things, because it's good at pulling apart positives and negatives in other compounds. Okay, thumbs up if we feel good about that, thumbs down if we're confused about any of that. All right, guys, you should be filling in number 3, the green checks when you have that saved. And go ahead and give you guys 20 seconds. Go, go, go. Green checks, please. Perfect. Okay, guys. Green checks, green checks. Awesome. All right, moving on. Thank you. All right, so here was our objective for today. Ionic, covalent, polar, nonpolar, smiley faces if we feel good about that. Thumbs down if we're confused about any of that. Awesome. You guys did great today. Okay, so I'm going to go ahead and send you the quiz really quickly. Remember, do the quiz with the attendance ticket still open because all of those yellow boxes we just filled out are the answers. Remember, yellow boxes are the answers to the quiz as well. Here's your last word. Thank you so much, guys. If you missed anything, it will be in the recording later because I do need to go to my next class. Bye, everyone. Go ahead, log out. I'll see you all later. Have a great day.